So exercise 45, question number 9. This particular one is quite a tricky one. We've got two resistors and we know something about the resistors when they're in series. We know that they've got 40 ohms when they're in series, and we also know that when connected in parallel their total resistance is 8.4 ohms. Well, here's a little bit of information about resistors. To get total resistance for two resistors in series, you just add them up, R1 and R2 in series. The same two resistors in parallel, it will be the product over the sum, a formula you might be familiar with, R1 times R2 over R1 plus R2. Thinking about those two formulae and using the fact that one of these resistors might be Rx, which I think is what you're asked to let it be, yep, then what would R2 be? If you know that they're in series, they're 40 ohms, you could write an expression for R2 and then go from there. I will go through the solution step by step, and then at any point you can pause and see if you can carry on. So what I can form from the two series resistors is that Rx plus, now the other resistor, if they add up to 40, must be 40 minus Rx equals 40. And in parallel, we know that, which is the interesting one, we know that R1, which is Rx in this case, and R2, which is 40 minus Rx. So we know that product Rx times 40 minus Rx over the sum Rx plus 40 minus Rx equals 2.8 ohms, isn't it? No, 8.4 ohms. 8.4. So now I can try and rearrange that little equation to get a quadratic equation in the form ax squared plus bx plus c. See if you can do that, and I'll go through the solution. Again, at any stage you can pause it and see if you can carry on with it. So multiplying out the top, I get Rx times 40, which is 40 Rx, minus Rx squared, so that's my Rx, that's my square term, over Rx, really the bracket's not necessary because it's like 1 times 40, which is 40, 1 times minus Rx, which is minus Rx, equals 8.4. We can see at this point that at the bottom Rx's cancel out, so that you're left with 40 Rx minus Rx squared all over 40 equals 8.4. Now I would multiply through by 40, so I get 40 Rx minus Rx squared equals 8.4 times 40 equals 336, and now I would get all terms on one side, so it equals 0. We can use the quadratic formula. Because this term is negative, I would add that to both sides, so I'd actually try and make the left hand side 0. So I'd end up with 0 equals Rx squared plus 336 minus 40 Rx. So rearranging it so that it looks familiar, Rx squared minus 40 Rx plus 336 equals 0. And now I can use the quadratic formula on it to solve it.